A flush mounted reducer bushing is a pretty handy fitting, especially in tight spaces, but it's a very difficult component to create. But before we get started with that, you're going to want to make copies of the files we're going to be working in. This is PVC, by the way, PVC Schedule 80, and the stock catalog and spec files are the bare bones. So before we start editing in them, you're going to want to go in and make a copy of the catalog. You're going to want to make a copy of the spec. Copy, paste, rename it however you want to do it, but save a master in case you booger up the one you're working in. Now, what makes this fitting so difficult is you have a start point for the main about here going that way. You have a start point for the reduction here going that way, and between those two start points you have an overlap of pipe. Now it works in the model, but when it comes to producing a plot for isogen, you get an overlap pipe error and the plot file comes out all boogered up. So the way we overcome that is by not overlapping the two pipes. I have a small space there. So to get started, you open up the files that you just made, right? And you go into the data tables, and I use the reducer bushing, and it's copy, and then down here, rename. Now you'll notice the reducer bushing, or the coupler, has two end types. So we're going to take those two end types, one for the main, start, one for the reduction, and we're going to go up and take those data tables and do the same thing, copy and rename, copy and rename. When you open up your copied file, you're going to get the original data, stock Windows commands, pick the top one, hold shift, and remove. To add lines or sizes, right click at the bottom, add size, go through and pick out your sizes. Same with the end type styles. For the I've done a diagram to show what to put in these fields to get this fitting to work. Once you've filled in all of the data fields here, you're going to save it and then open up your project spec file. Let me hit on this, the isogen identifiers. That is a PDF file that can be downloaded, and it gives the information you need to fill in the key and the identification, and this is just typed in. This is a fly down where you go through and select your isogen key. On the reducer size, on the end type sizes, I want to bring to your attention, this is the main size. It is not a socket weld. It is a male, what did they call it? Male part. Okay, so that's for the large size, the main size. The reduction size is a socket weld part. You want to make sure you get those so that your isogen, your symbol, looks like it's supposed to. Anyway, once we filled all these in, and I'm going to fill a data field in here so I can save it out. These data fields have no effect on our part, but it does give me a save. So now when I go open the project spec, because I've made changes, it's going to ask me if I want to update the project. Yes. Now when you first create the fitting, it's going to be under couplings. It's not going to be there. You're going to have to add it. Right click, add, and you come down here and you fill in the fields. And your data table, that's the one you created for the fitting. Your sizes, if they're not there, go over here and you can select your sizes. And on a side note, I could find no 22-inch Schedule 80 PVC in my research. Got to do the same for your end types. Start and finish. And you notice the isogen symbol there. Isogen data that we took from the PDF file. Add your long and short description. I just kind of copied the format they had for the couplings. And then you've got to hit add and your part will appear. Now, if you don't know what catalog you're using, you can always go up here, right, and go through and find the catalog that you're using. And it'll load up. When you get all that done, you save it. And then you have to reload it over here, right? Now, let me show you. This is that fitting done with a socket weld for the main size or the start connection. This is a male part, and this is what we have. We have a bushing fitting inside our main pipe size. That's why it's important to make sure you catch that in the isogen portion of these. And that pretty much covers just a cursory view of the spec editor. And instead of me trying to explain what goes in each of these fields for these different data tables, what I did was create this diagram with an explanation of what goes in each field and where to get that information. One thing I want to point out is pipe dimensions. Cadworx lists the inside diameter as the nominal diameter, or the nominal diameter as the inside diameter. But as you can see here, that is not the case. And where it begins to make some significance is in 14 above. The nominal is the OD, and the inside diameter is considerably smaller. Now, it may work in all of the other applications, but for this application, you're going to want to use the average inside diameter for the nominal size of the pipe when you start filling in these data fields. This is might also be kind of handy. It converts fractions to decimals, and yeah, that's about it. Um, I also looked at, since it is technically a reducer, I looked at using a reducer and a reducer bushing, and what I did is I took the reducer bushing from another spec. I believe it was stainless steel, but they're all the same. Anyway, there just wasn't enough data in here as there is in here to make the fitting work, so that you got a fitting that had a spigot end and a socket end. Anyway, I think what I've got here is self-explanatory. This dimension is the only one that's kind of tricky. This dimension and this dimension are accurate, and this outside dimension is accurate. Couldn't figure out how to get a lip on it though. Um, this number, when added to this number, has to be less than that number. That's so you don't get an overlap in here. All right, there it is. Hope this helps.